Okay, number 2, let R be the region enclosed by the graph of f of x equal x to the 4th minus 2.3x cubed plus 4 and the horizontal line y equals 4 as shown in the figure above. Part A, find the volume of the solid generated when R is rotated about the horizontal line y equals negative 2. So we're going to, here's the line negative 2 down here. And we're revolving it about that line. And we're finding the volume. So since we're finding the volume, if this is a horizontal axis, so we're going to be using the disc or washer, that's definitely going to create a gap. So we're going to be using the washer method. So to get the volume, it's going to be pi. I'm going to go from where they start to where they end. This will definitely be from 0 to where they intersect. So if you find that point of intersection is 2.34. So we're going to go from 0 to 2.3. And then the outer radius, if I look at this figure right here, and I draw a line, which one of those dots is furthest away from the axis? It's going to be this one right here, so it's the horizontal line y equals 4. But then we do have to, because I'm revolving about the line y equals negative 2, we need to move this line up to the x-axis. So we're going to move it up 2, so this time we're used to subtracting, but this time we do have to add because we have to move that line up. So we're going to add 2 to it, that will be squared, minus the inner radius squared, so the curve that's closest to that axis of revolution would be x to the 4th minus 2.3x cubed plus 4, and again we need to add 2 to it because we have to move things up 2 squared, and then so that would be what I need to do, and then we are allowed to use our calculator on this one, and we use our calculator, we'll get 98.868. Alright, this was worth 4 points, so that's kind of nice. We're going to get 2 points for the integral setup. I'd probably say we'd get 1 point for this part and 1 point for that part, and then we'll get 1 point for our limits. So just by putting 0 to 2.3, you're going to get a point, and then 1 point for the correct answer. So again, this part was worth 4 points. All right, part B, region R is the base of a solid. So again, we're going to get that region again. For this solid, each cross-section perpendicular to the x-axis is an isosceles right triangle with a leg in R. Find the volume of the solid. So we're perpendicular to the x-axis, so we want things in terms of x. So our volume is just going to equal, we found in part A that we're going to be going from 0 to 2.3, and then we just need to find the area of that cross-section, and it does say the area is an isosceles right triangle. Any triangle has a formula of 1/2 base times the height. If it is a right triangle, an isosceles right triangle is going to look like this. Is a right triangle. We have base and height, but if it's isosceles, the base and the height are the same, so we could call them the same letter, so I'm just going to call them both b. So my formula is really going to be 1/2 b squared. And now I just need to find the base. The base is just going to be this length right here, so it's just going to be top minus bottom. So when I go to write this, it's just going to be the integral from 0 to 2.3, 1/2 base, which is going to be the top minus the bottom, and definitely use parentheses on this one because otherwise you'll probably get a wrong answer. And then that's squared, and then that's my setup, and if I type it in my calculator, I should get 3.574 for my answer. Okay, this one is worth 3 points. We're going to get 2 points for this part right here. So I'd say minus any mistakes you'd have, you just subtract 1. So this is worth 2, and then you get 1 point for the correct answer. You don't get any points for putting 0 to 2.3 this time because we already did that in part A. Okay, part C. The vertical line x equals k divides R into 2 regions with equal areas. Write, but do not solve, an equation involving integral expressions whose solution gives the value of k. So we're finding some sort of vertical line k, x equals k, that's going to separate this into 2 regions of equal area. Okay, we know the entire region goes from 0 to 2.3. So basically this is saying we're talking about in area. So the whole area is going to equal, I'm not even going to write that yet. The whole area is going to be 0 to 2.3. And then we would just do top minus bottom, so that's going to be 4 minus the expression x to the 4th minus 2.3 x cubed plus 4 dx. And when we do that, we do want to end up getting, I found an answer for this one. When I did this, I got 3.218. Okay, so we want to end up, our x equals k is going to divide this into two regions of equal areas. So if I divide that answer by 2, I will get 1.609. So I want to, this time, I don't want to go to 2.3, I only want to go to k this time. So my integral setup is going to be 0 to k of the top minus the bottom again. And I know that my answer has to equal 1.609. So I did write but did not solve my equation. So that's what we're looking for. We would get, this is worth 2 points. I'd get 1 point for finding the area of one region. So when I found this whole thing, that would have been worth a point. And then my setup would have been worth another point when we did that. Another way that we could have done that, this whole thing had to go from 0 to 2.3. I could have split it, so I could have said the area from 0 to k, just in case you did it this way, I wanted to show you this, plus the area from k to 2.3. 4 minus x to the 4th minus 2.3 x cubed plus 4. Actually, I'm not going to put plus. Those two would have to equal each other, because k separates them into two areas, two regions of equal area. So that would be another equation that you could have instead of this one, especially if you didn't have a calculator to use for that one. So there we go, number 2 is done.